our project is the physics of basketball. So understanding the physics of basketball can be very beneficial to a player of the game. Specifically, understanding the physics behind shooting, passing, and dribbling the basketball are the most beneficial and critical. Perhaps the most interesting piece of the physics of basketball is seen in this shot. There are two main points of emphasis on shooting the basketball: the shot itself and the spin on the ball.
Here I am shooting a jump shot. In the jump shot, there is little horizontal movement because the jump shot deals more with vertical movement. The ball itself is pushed off your fingertips, and the force and angle is applied upon release.
Here, Nick is shooting a layup. The layup is based more on momentum than the jump shot. The equation for momentum is P, which is momentum, equals mass times velocity. The velocity on the ball is the sum of the shooter's speed and the ball's speed. Nick will jog at around 3 meters per second. The ball speed is around 10 meters per second. The mass of an average basketball is 0.62 kilograms. So our momentum will be 8.06 kilogram meters per second. In the case of a layup, the ball doesn't need as much force and is basically dropped into the basket.
Aspect of basketball where calculating the physics can be interesting lies in passing. Here, we see Donald and Nate passing the ball back and forth. The idea of catching a pass can be analyzed using the equation mass times velocity equals force times time, or force equals mass times velocity over time. These are the equations for impulse. And using this idea, the greater the time is, the lesser the force will be, and thus the pass will be a lot easier to catch and not drop. Each pass takes about 1 second to reach its target. Mass is 0.62 kilograms. Velocity is about 4 meters per second. So, our force that is being applied to the ball is 2.48 kilogram meters per second.
Let's take a look at dribbling. This aspect of the game concerns the potential and kinetic energy the ball has. Here, Nate is dribbling the ball. When the ball is held, the ball has potential energy. Upon its release to the floor, potential energy converts to kinetic energy. Potential energy is mass times gravity times height. Our ball is 0.62 kilograms. The height is approximately 1 meter. Gravity is negative 10 meters per second squared. So, our potential energy is 6.2 joules. Kinetic energy is 1/2 the mass times velocity squared. Let's assume that the velocity is 4 meters per second. Our kinetic energy will then be 4.96 joules.
Let's take a look at the spin of the ball. The spin on the ball and its significance can be a fairly surprising topic to most people. The spin used on a shot during its time in the air is really irrelevant. The spin really only comes into use when the ball hits either the rim or the backboard. Once the ball hits the backboard, the velocity of the ball changes. Backspin on the ball will allow the ball to continue in a vertical path, allowing the ball to have a greater chance of going in. A ball without backspin will more than likely just bounce off the rim or backboard and will have a significantly lesser chance of going in.
As you can see, physics is present throughout all of basketball, whether it's shooting, dribbling, or passing. We hope you enjoyed our video presentation on the physics of basketball.